10-1 intro. Review, you have this good. You have this in Math 1. Whenever we do these problems, you don't have to go through all the steps I'm going to go through right now. We're just going to know where the rule comes from, though. And some of you already know what to do here, but please follow along with me as I try to explain why. What does a to the third mean?
It means a times a times a.
Perfect. A times a times a. That's the same as a cubed. Good. It means 3 a's multiplied together. What does a to the fifth mean?
A times a times a times a.
5 of them. Good. Write that down. Like I said, you're not going to write that down every time, just for this rule sheet, so you know where it's all coming from. Yeah. Because see, you have 3 8s here and 5 8s here. When they're all multiplied together, how many a's are actually being multiplied together? 8 of them. You can count them up. There's 8 of them. So now what you guys are used to doing, when you see these two exponents, what's the rule to do now? Add them together. Good. You can abbreviate this right here, but what I'm going to tell you is when you have two of the same variables being multiplied side by side, that's when you add the exponents. You can write a shortcut. You don't have to write out all those words, but you have to know that there are two variables being shown. There's 2 a's. It's written twice, and each of them has separate exponents. Because if you only have one a with different exponents, it changes the rule. So whenever you have two of the same variable, that means you add them. All right. Anybody still writing? Okay, so turn the page now. We're only going to do one rule for today. Let's go over to 10-1, multiplying powers.
No, we're going back to the book
No, I didn't quite get that.
Hey, yeah,
Okay,
that's
yeah.
true. Mr. Betsy, it's like whole year we started.
Mr. Batsky, I don't want to use that.
Yeah. Whatever you say, Mr. Betsy. Whatever you say.
Use them at the beginning, but the problem with them is that, well, I don't think they're well organized. I don't know. You end up having to skip over half the page, and I'm like, I just cut and paste. All right.
What time is it? Oh, yeah, Mr. Batsky?
Had a birthday? All right, you guys, let's get our notes done. All right, so look. Here's the general rule. A to the m times a to the n equals a to the m plus n. When you see the exponent and you see the base separate, that's when you add them. And tomorrow or another day, I'm going to show you that's different. Do you have a question? Alrighty, so for example, one's like this. This example. There's 3 bases that match, and each one has their own separate exponent. What's this exponent right here? An imaginary one. Good. So 1 plus 3 plus 3 is 2 to the 7th. Okay, tomorrow and in the next days, I'm going to teach you how to do 2 to the 7th on your calculator. If you don't already know, you will. But for today, you can leave it written like this. Number 1. Let's go through this quickly. That would be 3 to the what power? Third. Good. Because this is a 2, but this is an imaginary 1. 1 plus 2. When they're separated like that, you add the exponents. For this one, what's the base going to be? 4. And what's the exponent going to be?
Yes.
Is that a 3 and a 3? Alright, what's this one going to be?
2/3.
2 to the 3rd. Good. This one?
Yes. 6, 5.
No, what's the base? 3.
Oh,
Good job. Excellent. The base doesn't change. In this one, the base is negative 4. What's the exponent going to be? 5. Now think about this. If we have negative 4 times negative 4, don't write this out, times negative 4 times negative 4 times negative 4, is that answer going to come out positive or negative? Good, because these two will cancel, and these two will cancel, and then one negative will be left over. That's right. Alright, next one. Alright, write this down. Underneath number 19 here. First thing you have to do is multiply coefficients. And one of the things I'm trying to instill in you right now is that a coefficient, a number out in front, does not follow the exponent rules. The only exponents that are small and on the other numbers, those are the only ones that follow the exponent rules. Coefficients are the numbers out in front. The second thing you're going to do is add the exponents for matching powers, matching variables. Add the exponents on the same basis. They both have a base of A, you can add their exponents together. So the very first thing you have to do is separate the coefficients from the rest of the ones that have exponents. So this is a coefficient because it's a number, it's a whole number that's in front. What's another coefficient? Good. What's the imaginary coefficient right here? A 1. Good. So the first thing we do is multiply the coefficients. 3 times 4 is 12. There's no other numbers there. Write that down. And x, you have x to the 4th, and you have x to the 4th, and you have x to the 1. So what would that make? 9. Good. X to the 9. And then you have y. And we usually write them in alphabetical order. Y to the 2nd and y to the 3rd. There's no other y there. If you get a negative exponent for today, don't worry about that till we cover that. It'll be a couple of days. Alright, so let's go through these quickly. I'm gonna skip one and do one, then you do one. I'll do one, then you do one. Number 11. Here's a coefficient of 3. Here's a coefficient of 2. Those have their own rule. You just multiply them together. That 3 times 2 is 6. Now I have to do my A's and my B's. A to the 4th and A to the 1st. So that would be A to the 5th. B to the 3rd and B to the 4th. B to the 7th. Okay, that's all you do. Multiply the coefficients and then find all the matching bases. It will get more complicated as we go throughout the chapter. Alright, you do this one. Yes, this is some review of Math 1. But we're going to be adding some fraction exponents. We're going to be building into it, getting ready for Math 3. Alright, so 3, do that, and then do your x's and then do your y's. Do that on your own. Okay, so did we get 3 out in front?
Yeah.
What did we get for the x's?
3.
And for the y's?
6.
Good. Alright, this one now has a negative. Let's talk about the negatives. The coefficient has to come first. 3 times 3. So that's going to be 9. Now, when you look at the u, you have a u to the 1 right there, and a u to the 4, u to the 5. Good. Now look carefully at the b's. B to the 3rd, and b to the negative 3rd. 3 minus 3 makes what? They cancel each other out. You have b to the 0. So how many b's are there? None. So we won't put b in our problem, in our answer. Okay? Don't worry what I'm about to do. Does this look familiar to you? Whenever you have anything to an exponent of 0, it always equals 1.
Oh, yeah.
We're going to talk about that more later, but that's the reason why. So second equals 1. Alright, number 17, you try negative 2 times 1, and try out all your x's, your y's, and your z's. Alright, just do the problem, please. Does anybody need more time? Okay, this is out of order, but go in alphabetical order. So this one's x to the 3rd, if I'm reading it right. This one's x to the 1st. So we get x to the
X to the 4.
Y to the second and Y to the second.
Z to the third.
Z to the third. Good. Go in alphabetical order. Make sure they match. This, it's just customary.
Yeah, why?
Z to the first and Z to the second. It's just the standard way of writing. Alright, and last one, let's do together. -4 times a +4 times a -3. No, this is not the exponent. These are the coefficients. So it's going to be a negative. 12 times 4, we're going to have -48.
No, because -3.
Ooh, extra credit, Mr. Red. Positive.
It is the positive.
Extra credit. Extra credit. Extra credit.
Yeah, I heard Eli first. Alrighty. Don't do that to me when I'm in a rush to make you guys get started on quiz. Alright, so Eli will get that one. Right, 48.
Oh, yeah.
Now, we have a P to worry about, we have a Q, and we have an R. So for all the P's, I see P to the fourth,
7.
P to the third, and then you take 2 of them away. Good, so that's 5. P to the fourth and the third makes 7. Take 2 away, you get 5. Q. Q to the second, Q minus 1, so that makes Q to the first. And then Q to the fourth is 5. Sorry, add them together, you get 5. R. There's no R's here, right?
3.
And then this one's R to the first, R second, so R. Okay, so that's the basics of it. Now, we have to take this knowledge and we have to turn it into problems with the scientific notation. So we have to use what we did the other day. Anyone still writing?
No.
Okay, so when you look at scientific notation now, I know this is all in parentheses, it's a long problem, but these are the coefficients right here. You multiply those together, and these here in yellow, you get the yellow here.
Oh,
These are the exponents that match, or the bases that match, okay? So you do 9 times -6, and you get -54. That's the coefficients. Now you do 10 to the -4 times 10 to the -12. Since the 10s match, you add the exponents. Good. And you put the times in between. Okay? But this is a problem like Friday, where we have it written with a power of 10, but it's not truly scientific notation. What's wrong with it? The negative exponent is okay. The rule about scientific notation is the decimal go. Where should the decimal go? Good. Where is it right now? At the end. So we have to go from the dot to the x. What does that mean? +1, you're going to the right. Some of you are going to get to where you can do this mentally. You can think +1 minus 26. I'm going to write it all out.
So that means -5.4 times 10.
Hold on, watch me. Let's do it together. Alright, so watch this. I'm going to ignore this just for a second. Are you concentrating? Ignore this just for a second. Let's do this one. It's -5.4 times 10 to the, we said it was +1. From the dot to the x is +1. See it? But the rest of the problem says you still have to do times 10 to the -26. Times 10 to the -26. So now what you have, times 10 to what now? This is a +1 and a -26. Those all match. So add it. -20. +1 minus 26 makes our final answer -5.4 times 10 to the -25. That's important because now the decimal is in the right place. Some of you are going to get to where you say, oh, that would be +1. So in your mind, you would do +1 minus 26. But I'm going to keep writing it out. Okay, get conversations focused up here, please. This is the hardest part. For this one, take your coefficients and multiply them together. The numbers out in front are your coefficients. 5 times 0.6. Do that in your calculator if you don't do decimals in your head. This comes to 3. Good. Times 10. Combine the 10s now by adding the exponents. Negative 6. Positive 4, negative 6, or negative 10. Just like we did on the x's and the y's and the z's. Now we're just doing it on the 10s. Positive 4, negative 6. Now we stop and look. Do I have to move the decimal here? No. So in this case, it's already done. Somebody, please explain to me why I didn't do more work.
Because there's a point and there's already 0.
There's only one number.
Yeah, the decimal's already in the right place. Good. This one didn't have the decimal in the right place to begin with. All right, number 23. Try that right now. Just 23 on your own. Do the two numbers multiply together first, and then combine. I'm sorry, I just need to do the first step. Multiply these together first, and then combine the powers of 10. Just the first step, and then stop. 10 to the negative 8, right? Okay, can I stop here?
No.
What's wrong? The decimal's wrong. Good. That needs to be written as 1.8. So the first thing I'm going to do is ignore this, and then I'm going to concentrate on the 1.8. And the decimal here is the one that I want to go away, and this is the one that I want. So that means I move my decimal which direction?
Right. Positive.
Negative left. You have to end on the x. The x is where you stop. Okay? You start at the dot, you end on the x. It goes to the left, one place. So some of you already mentally think of that times the negative 1. I'm going to write it out. Times 10 to the negative 1. But that's only this part. I also have to take this part and continue it. That's times 10 to the negative 8. So my final answer is what?
1.8 times 10 to the negative 9.
Excellent. You can do it the way we did on Friday if you want, but that's a lot of moving decimals and stuff. So. All right, do number 24. Do step number 1 on your own. It's 3. Times what? Okay, what do I need to do next?
Nothing.
Good, why?
Because
The decimal is in the right place for scientific notation.
yeah.
Turn the page, and while I stamp your homework, I want you to do the bottom 5 questions on the last page. Some of them are already going to be done after your first step. Some of them are going to require you to go one step further. Do number, I think it's 15 through 21, but I'm going to double check.
15, 16, 17, 18, 19.
Yeah.
Okay. 21, read that word problem. Read it carefully. And see what you should do. Alrighty. My turn now. You guys stop talking. Number 15.
6 times 10 to 15. Hey, get it.
What do you do?
Oh,
The
8.
8. Good. The front numbers don't follow the same rule. This is times. Alright, nothing further. 8 is the same as 8.0. That answer is fine as it is. Number 16.
Negative 9 times
And you don't have to change it because it's a decimal right after the 9. Questions on those? Alright, number 17. What do you get? Did you have to do anything to that? No, the 1.8 is fine as it is. Number 18. What do you get for the first step?
7.5 times
Okay, so you get the final answer. The middle step was 0.05 times 10 to the negative 11.
10.
And then you have to move this one 2 places over. Any questions on number 18?
Wait, how did you get negative 3?
Yeah, I got negative.
Alright. Quiet, please. Because you move the decimal here and you cross off that one, it goes to the left 2 places. That's like 7.5 times 10 to the negative 2. 2 places. So then you do negative 11 and negative 2 makes the negative 30. Any other questions? Alright, number 21. I know the numbers are off because I've done a lot of cutting and pasting and I don't always go back and fix the number. Well, what's happening here? What about Kermit? Okay, that's how many votes he got, and then what happened?
Miss Piggy received approximately 1.4.
You received that many times Kermit's votes, right? So we multiply that. I'm going to stop 1.4 times 10 to the second. That's how many more times votes she got. She got like 140 times more votes. So, how do you figure out how many votes Miss Piggy got? You multiply the 5.9 times the 1.4. Put it off, please. Just silence it.
Hold on, Miss Mansky.
And you get 8.26 times 10 to the 9th. Well, yeah, how many votes? Well, I just multiplied Kermit's times hers. Did that it? Did you? And then went back? Well, it's just the directions, just that time.
Yeah.